to another MAT video again. I took a long break of MAT, did a little problem, enumerated polyhedra, wrote a Pi Day and Tuesday special, and now this. This is a really interesting MAT question going back to 2008. This is question 1B, just to let you know. Now, we need to find the smallest of these numbers. Well, how do we do it? We don't have calculators. How do we find log 10 pi? Well, you have to go back and thank your forefathers for this one. So back in the days when there were no electronic calculators, electronic calculation wasn't a thing, there were things called slide rules. Slide rules were really versatile tools, and they were the most advanced and popular calculating tools for 300 years. And you know why it's so useful? It's because it had a logarithmic scale which facilitated multiplication. So basically, you had two normal 15 cm rulers. Try doing a simple sum like 2 plus 3 on those linear scale rulers. So let's draw some linear rulers here. Obviously, so you have 1, 2, and since it's at 0, then you have 1, 2, 3, and then when you look at this, it is 5. So it works the same on multiplication on logarithmic scale rulers. It all boils down to the identity log A plus log B equals to log AB. And since we done the addition procedure here, we can use this identity to find the multiplication of any two numbers. Now, what has this got to do with pi? Well, we can find the square root of A. So basically, the log square root of A equals to half log A. And back in the days, these logarithmic slide rulers had a base of 10. So log times the square root of 10 equals to half times log the square root of 10. Now, actually it's 10. Now, why do I say this? Is because square root of 10 is very, very, very close to pi. So this is very approximately close to pi, and they place pi in the halfway point between 1 and 10 on the logarithmic slide rule, simply because pi is a more useful constant. Now, using the identity log 10 pi, since log 10 is 1, equals to half. Let's just trick the mathematics a bit and use this. Now, since we already found this, A is half, B is a bit harder. Then log 10 pi squared equals to 2 log 10 pi. So you knock down this power and multiply. So 2 times half, which you all know equals to 1. Then what is the square root of 1? It is 1. Even with these approximations, we can find question C. Now part C. So we need 1 over half cubed equals to 2 cubed equals to 8. So this is approximately equal to 8. Now, what is log 10, the square root of pi? Remember we've seen this here? Log square root of 10 is half log times the square root of 10. Now, this is true for anything. Log pi equals to 2 log the square root of pi. So when we trick the mathematics into telling us that log pi is half equals to 2 log square root of pi, the log is at base 10 now, log root pi equals to a quarter. So 1 over log 10 times the square root of pi is 1 over a quarter is equals to 4. With that in mind, we can say with confidence that A is the smallest number. Hey, so some fun facts about pi. Well, what's so interesting about pi? Well, pi squared is almost equal to the gravitation on Earth, 9.81, but pi squared is 9.86. Because when you're doing Cambridge exams, the gravitation is taken to be 10. I think that's a really good approximation for people who are just starting in physics and mechanics and further mechanics. But I think, in my opinion, when you want to study advanced physics, you can take g equals to pi squared and you won't go wrong. And you know how you won't go wrong? Well, if you find the period of a pendulum, t equals to what? 2 pi root L over G. So t equals to 2 pi root L over G. And if you take G is pi squared, and you take L equals to 1, then it's 2 pi root 1 over pi squared equals to 2 pi over pi equals to 2. So if G was exactly pi squared, we'll have exactly 1 meter long pendulum for our pendulum clocks. Unfortunately, gravity doesn't let us go and decides our pendulum clocks. And besides our pendulum clock's pendulum should be slightly larger than 1 meter. Gosh, you think those forefathers were intelligent? Well, I'll tell you something. The 4 very important mathematical constants are gamma, phi, e, and pi. And if you multiply each by 71, yes, 71, you will get an almost integer. An even better approximation is that when you multiply by 71 times 9 is equal to 639. Let's just write this down for all of you to marvel at this magical number, 639. So that's why I always thought of this magical constant that when you multiply by any prominent mathematical constant out there, it will output an almost integer. And that's one of the marvels of 639. You take the 4 most common mathematical constants, when you multiply it by this magical integer, everything will output an almost integer. See you, bye!